Welcome to the front lines of defense. This is Indian Defense Affairs.
In an evolving regional threat environment where hypersonic weapons and complex reentry vehicles redefine strategic deterrence, traditional air defense networks face unprecedented demands. India's Defense Research and Development Organization, DRDO, has initiated conceptual and engineering work on Phase 3 of the Ballistic Missile Defence (BMD) program. While Phase I deployed two-tier protection against medium-range targets and Phase 2 expanded coverage to 5,000 km class ICBM threats through the AD-1 and AD-2 interceptors, Phase 3 pivots toward an even more formidable challenge: high-altitude interception of hypersonic glide vehicles, HGVs, and fast re-entry maneuverable warheads. The hypersonic paradigm shift. Traditional ballistic missiles follow predictable, parabolic Keplerian trajectories. Once launched, tracking radars can calculate their speed, angle, and splash zone with high precision, allowing interceptors to execute a programmed hit. Hypersonic weapons disrupt this predictability in two fundamental ways: high maneuverability inside the atmosphere. Hypersonic glide vehicles, HGVs, fly at speeds exceeding Mach 5 along the upper edges of the atmosphere, 30 km to 70 km altitude, skipping and weaving to evade ground-based radar tracking. Extreme heat and velocity, fast re-entry vehicles and hypersonic cruise missiles generate intense thermal plasma clouds around their airframes, complicating infrared and radio frequency seeker acquisition. The Phase 3 architecture, ADA and ADAM. To counter these weapons, DRDO's Phase 3 initiative centers on two high-altitude interceptor concepts. ADA, Advanced Defense Anti-Hypersonic specialized for upper atmospheric and near-space engagement of high-speed gliders. AD-AM, Advanced Defense Anti-Missile tailored for atmospheric interception against maneuverable, fast re-entry ballistic warheads and hypersonic cruise missiles. High-altitude interception and kinetic precision. Intercepting a maneuvering hypersonic threat at altitudes between 40 km and 100 km requires extreme kinetic responsiveness. The Phase 3 interceptors are engineered with reaction control systems, RCS, microthrusters positioned around the missile center of mass, allowing instant directional corrections in thin air where traditional tail fins lose aerodynamic control. Furthermore, Phase 3 integrates multiple independent target tracking, MIT, and AI-driven predictive algorithms into the Mission Control Center, MCC. Rather than relying on simple course extrapolation, command systems continually recalculate intercept points in real time based on sensor inputs from satellites and long-range tracking radars, LRTR. Strategic significance. By extending interception boundaries both vertically and horizontally, DRDO's Phase 3 shield aims to close critical operational gaps in national air defense. Protecting vital metropolitan, command, and strategic infrastructure against unpredictable hypersonic weapons ensures that India's defense posture remains robust against modern missile developments across the Indo-Pacific.
This is Indian Defense Affairs.